Hello, friends, and welcome once again. And in today's session, we're going to have a special look at approximation. Before we start with approximation questions, concepts, and tricks, let's have a look at this wonderful quote by Madame Marie Curie. Madame Marie Curie is one of the Nobel laureates, and she was the first female to get a Nobel Prize in the year 1903 on her discoveries on polonium and radium elements, and she was also the first university professor to teach in the University of France, right? She says that nothing in life is to be feared, it is only to be understood. Now is the time to understand more so that we may fear less. In these uncertain times of coronavirus, we are living under a fear, and it is imperative that we understand how life works, how things work, and how we can sail through these tough times, right? Pretty apt a thought even today. So, in this video series, we're going to take up these many topics. We've already done a small session on simplification, and today we'll be doing session number 2, and that will be approximation. So, just a sec, approximation. And I've taken up 10 questions on approximation that will help you to understand the concepts and the tricks associated to this particular topic. And the other topics that we'll be covering in days to come are over here. So let's have a look at approximation. The very first session will be today. Let's have a look at the first question. With the help of these questions, I'm going to explain you the relevant tricks, the relevant concepts, and wherever an emphasis has to be given on a certain concept, that will be done, right? Let's have a look at the first question. What approximate value will come in place of the question mark? In these given questions, you're not expected to calculate the exact value. Now, let me first tell you one important thing is that whenever you will be facing questions on approximation, you will be given all the 5 options. Very rarely will it happen that the fifth option would be of none of these, because you are expected to calculate the approximate value and not the exact value. So it is imperative that if you are calculating an approximate value, it has to give you an answer, right? First thing. Second thing you need to keep into mind is that it is not necessary that if you apply the logic of approximation and if you arrive at an answer or a value, it should match with one of these 5 values. Even though if your answer is correct, even though if your calculation is correct, you might not land up with an option which is going to match with the 5 given options over here, right? Because your approach of approximating values will be slightly different than the one that the examiner expects you to follow, right? So in that case, you have to pick up the option which matches the answer, which is closest to the options given over here, right? So let's get started with the very first one. The first one, let's have a look. The first one says 105.27% of 1200.11 plus 11.80% of 2360.85 is equal to 21.99% of question mark plus 1420.99. Since we're approximating, we can round off these values to the nearest integers. So this thing can be written as my mistake, let me erase 5. This can be rewritten as say 105% of 1200, right? Plus 12% of 2360. This should be equal to 22% of x plus 1420. Now I am deliberately not mentioning it as 1421. Why? Because if I'll have 1421, it will become more difficult to make calculations. So give or take, I have actually deliberately reduced the value by 1. So that's not going to change my answer a lot. Why? Because as you can see, all the options are pretty far away from each other. Second thing, I have not done this 100%. Why? Because you try and understand the number next to it is a big number. It's 1200, right? So 1% of 1200 is going to be 12 and 5% is gonna be 60. So if I round it off to 100%, that will make a variation of 60 and not a slight variation of 1 or 2 numbers. So that is a big change for this particular number, right? So it is sensible that you round off, and you round off in a way wherein the rounding off does not affect the value of numbers to a great extent. So rounding this off to 22 is sensible. Rounding this off to 1420 is sensible. Then rounding this off to 100% would make a big difference of 60. So you'll have to be careful while rounding off values which are in percentages, or whenever you're multiplying big numbers, or when you're dividing a big number by a smaller number. We'll be talking about them later, right? So 100% is 120 and 1% is 12. So 5% would be 60. So 120, sorry, 1200 is the 100%. So 1200 plus 60. Now this salt would be giving me 1260, right? Oh, plus 12% of this much. Now that's not a big deal. If you try and understand, 10% is 236. 10% is 236 and 1% is 23.6. So 236 happens to be 10% and 1% is 23.6, almost 23.5. Double of that would be 47. So you add 47 over here, which will be 3 carried over 1, 8, 283. So this is 283. Right? Oh, would be equal to 22% of x plus 1420, right? So this 1420, when it comes over here and is subtracted from 1260, so 1420 minus 1260 will be 0. 4 over here, 140. So we have minus 140. Let me make a correction. So 160, sorry, that's 160, not 140. Right, 160. So minus 160 plus 283 should be what? Should be 22% of x, right? So minus 160 and plus 283 is almost plus 123. So 22% of what should give you 123, right? So let's have a look. So 10% of this would be 31, 20% would be 62, and we are far behind 123. So anything less than 310 does not suit the bill. 10% of this is going to be 96, 20% is going to be around about 192, which is a large number. So this is again out of the question. 10% of this is 50, 20% is 100, and 22% would be 110. So this is again little less than 123. 10% of this would be 55, 20% would be 110, and then again 2% would be 11. So 110 and 11 is 121, almost there. So option number 4 is the correct answer. I hope you understood the logic, right? Let's move on to second question. The second question says, now this is an easy one. So 0.98%, 0.98% is almost 1%. So on 1% of 7824 is 78.24, right? So we leave it to 78 plus 4842 divided by what? 119.46, you make it 120 minus the question mark should be equal to 78. Now please try and understand. Now I can see that if I divide 4800 by 120, it makes my task a lot easier. Why a lot easier? Why? Because I can easily calculate it like say 40 times. But I have 4842 upon 120. So how much is the difference? The difference is 42, which is almost one third of this number. So even though if I forego this 42 and make it 4200, the answer is going to vary by say zero point 0.3 or something like that, right? So that's not going to make a big difference. So we can do this. But if I have say 4800 and I'm dividing it by 6, and then you say no, let me divide this by 4800 by 5. Now this is going to make a huge difference. Why? Because the denominator is very small. This would give me 800 and this would give me how much? 960. So that's a huge difference. Why? Because the denominators are pretty small in comparison to the numerators, right? So you'll have to be careful. So we can take it as 4800. So this will be 78 plus 40 minus the question mark is equal to 78. No need to do anything. 78 will get cancelled. We'll be left with 40 as the answer. So option number 3 happens to be the correct answer in this case. Right? Let's move on to the next one. Now, this is a very easy one if you have a look. 41.99 minus 18.04. No guesses over here. It is sensible to have it 42 square minus 18 square. Now let's say divided it by x, we're supposed to find x over here is equal to 13 square minus 138.99. So 13 square is 169 and this is almost 139. So 169 minus 139, on the right hand side you have 30. That's a no problem, right? Now you need not find 42 square and then 18 square and do it. You always know that a square minus b square can be rewritten as a plus b into a minus b. So a plus b over here will be 60. A minus b would be 24. 24 and 18 is 42 upon x. And this is equal to 30. This is it. That's it. So what you do, 2 times this goes away. So x would be equal to 48. If we have 48, great, or we'll have to look for some. Oh, wow. We have 48 bang on. Right? So we can go ahead with this particular option. Let's move on to the next one. Let's have a look at this one again. 24.96 square divided by 34.11 divided by 20.05 plus this much minus this much is equal to how much? So 24.96 is almost to 25 and square of 25 is how much? 625 divided by, so we have 34 on top. I'm talking about only this much part, right? 34 on top and 20 at the bottom will give me 1.7, so we'll divide it by say 1.7, right? Oh, plus this, let's treat it as 68 minus, let's treat it at 89 will be equal to how much? So this much when solved will be giving me minus 21. All I need to is to work out this one. So 6250 upon 17. And you know it very well. 17 threes are 51 carried over 11, 1 and 1. 17 fives are is 85. 17 six are is 102. So 36. And then we have a 13 over here. So 366, almost something like that. So 366. Almost. We are doing a rough calculation. Why? Because we can have a look in the options given to us. It's a pretty far off call, and all the options are pretty far away. So there's no need to be panicking. No need to do finer and detailed calculations over here, right? So 366 minus 21, you should get a value somewhere around 345, 346. So since we don't have a 345, but we have something that suits the bill, that is 347, pretty close to it, right? Didn't I mention that if you fail to get the exact answer as mentioned in all these 5 options, you're supposed to pick the one that suits your answer most, right? So 347 is the answer here. Now let's have a look at this one. So now again applying the concept of BODMAS, we are doing this part first because this is in the curly brackets. As you can see the curly brackets over here, and then we'll multiply everything by whatever we get. We'll multiply everything by 2.5. So 2.5, why? Because 2.532 we treat it as 2.5 alone, right? So let's do it, and let's see. 2.5, we have to multiply this. Okay, no issues. So 4, 4, 4 and 4, then we have got 3 threes, then we've got 2 twos, and then we've got 1 1. So 4 plus 3 plus 2 plus 1 is 10 carried over 1, 10 carried over 1, 7 and 1, 8 and 4. So we have 4800, and from this we will subtract how much? 2 threes are 6, 6 4 are 24, 25 fives are 120. So we leave it with 64680. So we have 4680. So 4680, 2.5 times. So that's an easy crack. And how do you do that? So you have to do it 2.5 times, or you can do it 10 by 4. So instead of doing 2.5 times, you can simply do it as 10 by 4. So multiply the number by 10 and then divide it by 4. So 4 ones are 4, 4 ones are 4, carried over 2, 700. So 11700. Do we have an option over here? Let's have a look. Do we have an option? 117 11700. Is 1. Let me just check. Have we done all the calculations to be double sure, right? 0 carried over 1, 0 carried over 1, 8 and 4, 4800, 23 is a 60. Okay, 120 subtracted perfectly. Okay, 46800 by 4, so 41. So 11700. This is the option. So option number 3 is the correct option over here. Now, why am I choosing this? Because we have multiplied it by 2.5, and it actually supposed to multiply it by 2.532. So the answer is going to be slightly more than 11,700. So 11749 is the correct answer. No issues. Let's move on to the next question. Now, this seems to be a little easy, huh? So 1.93 square plus 2.04 square divided by 2.04 minus 1.03 into 10. So again, we have a box bracket over here. So we'll be solving this much part first as per the board mass. So a square plus b square divided by this. Now this is again in brackets. Yes, this entire term is in brackets. So how do we write this? So this thing, you have to consider 1.93 as 2. So square of 2 is 4. 2.04 again rounded off becomes 2. So 2 square is again 4. Divided by 2 minus 1 is 1 into 10. So 8 into 10 is 80. So we have option 2 is the correct answer, right? Let's move on to the next part now. Root of 648. So I will tell you a quick trick how you can assume the values of the numbers which are not perfect squares. And as you know, any number which has a unit digit 2, 3, 7, or 8 is certainly not a perfect square, because any perfect square will never have digits 2, 3, 7, and 8 as the unit digits, right? So how do we go about it? Now you know that the square of 25 is 625. And 26 square is 676. Now this number falls somewhere in between. So let's assume that this is say 25.5 divided by 32 multiplied by square root of 225 is 15 divided by 45, right? Is equal to x by 48. That's it. So 15 threes are 48, and then you have 4 8s are and 4 12s are. This goes away 4 times and this goes away 2 times. Right? Oh, no, I've done something. Yeah, this is 25.5. Yeah, we're going on right. So all we are left with is 25.5 upon 2. So almost somewhere between 12 and 13 we'll get the answer, right? So 12 is the correct option over here. 12 is the answer. So it is 12.5. This was 25.5, right? So this is how you can get it done. Let's move on to the next one. 784.02. So you know very well 28 square is 784. Isn't it? 29 square is how much? Do you know that? Come on, tell me how much is 29? 841. Is it? Okay. Fine. So 28 square is 784. So we write it as 28 plus 4 would be equal to 1. Let's say the question mark is x divided by 1 divided by 5. So this 5 comes over here as a numerator. So we have 5x should be equal to 32. 28 plus 4 is 32, right? So 5x is equal to 32. So if 5x is equal to 32, so x should be somewhere between 6 and 7. Let's see, yes, 7 is an option, so we'll go with 7 is the correct answer. Option number 4 is the correct answer in this case. Let's move on to the next question. So what does this question has to say? 6498, root of that multiplied by root of 639. So you know it very well how to go about it. So all we have it over here is this root. We can see it like this: 6498 into 639 divided by 153. As simple as that. Or you can even think like this: 6498 I'm giving you a thought because you need to understand that this is not necessary that you apply the same approach every time. So whatever suits you, right? So that's the case. So what do we do and how do we go about it? So let's have a look. Which one do you want to follow? Let's take the first approach. We'll do it with both the approaches. Let's do it first approach. So 15 Forza is 600, right? So this will go away into this 4 point say something something times, right? Now we'll be left with a root of 4 point something, that will be again 2, and root of 6498. So we know it very well that square of 80 is 6400 and square of 81 is 6561. You need to be very careful with squares. Now, how was I able to do it? I know that root of 80 square is 6400, and if I need to find 81 square, all I need to is to add these two numbers. So 6400 plus 160 will give me 161 will give me 6561, right? So the value of this is somewhere between 80 and 81. So we have this, and 80 or maybe 81 multiplied by 2 would give me 162 or something like that. So option number 4 is the one which is suiting it the most, somewhere near 162, 163, right? This was the first thought of doing it. Now let's approach the question from the second perspective. Not cancelling out values inside the root, but rather having estimated or approximate under root values, right? So as I've told you, this is somewhere between 80 and 81. So we can have, say, for the time being, we can write it as 80.5 multiplied by 639. So 25 square is 625 and 26 square is 676. So this is almost 25 and 153. So 12 square is 144 and 13 square, you know it very well, is 169. So almost 12.5. So 12.5 and 25 two times. So we again land up with somewhere around 161, 162, the same answer we get. So regardless of whatever approach you are following to make an approximate value, the idea is that the original value of that number should not deviate a lot. While approximating a number, if the original value deviates, then the answer will go for a toss, right? Let's have a look at the last option over here. Now that's an easy one. Why? Because easy one. Why? Because see, whenever you have such questions wherein you have powers in decimals, so it is only sensible that you make the basis comparable. So for you to make the basis comparable, you'll have to have a look at the basis first, focus on the base, and then you can think of, solving it further. So can we not say this is 152 to the power of zero point 0.7? No issues over here. We will leave away 0.05. Multiplied by 38 into 4 is again 152. 32 plus 121, 52 to the power 1.3 should be equal to 19 eighths again is 152, and the question mark. So when we have a same base, the powers will get added. So 1 zero point 0.7 plus 1.3 will give you how much? 2. So the answer over here will be option number 5. Option number 5. 2. So I hope you enjoyed today's session. And in case you did, don't forget and don't hesitate to share, comment, and like. And also do let us know whether you would like to have more sessions or not. Other details are given in the description of the video. And please do share it with your friends and do let us know what else can we do to improve upon, and what else would you want us to come up with for these kind of things, right? So I hope these 10 questions gave you an insight and also helped you revise the entire topic. I'm going to see you there in the next session. Till then, bye bye. God bless you.